dialogue is a two-way communication. At the moment, I'm only speaking to myself. So I'm a multimodal dialogue person, which makes this even more weird. And what I'm interested in my research is building or researching whether we can build these systems using machine learning and to what extent these machine learning methods are actually suitable for building systems which are customer facing. And more recently, I'm looking into end-to-end neural generation, and in particular, the safety of these techniques. And in this talk, I will discuss the opportunities and limitations of these methods. So neural generation is actually really mainstream these days. I think probably all of you heard about the amazing things GPT-3 can do. In fact, it's so mainstream that even people outside of academia talk about it, even people outside of our field. Here is a tweet from MC Hammer praising the exciting things which GPT-3 can do. So now the question is, why do most commercial systems actually still use templates? And one of the answers to this question is that systems like GPT-3 aren't safe. So shortly after its release, it got bad headlines because it was sexist and racist, and it was also readily giving advice on very sensitive topics such as suicide, which is obviously not great. So to give you a little bit more background, GPT-3 is a large language model. Some of you might also have heard of BERT. And some of these large language models can be used to generate language. So there's the GPT-3 series, there's BART, there's T5, and so on. And recently, Emily Bender and colleagues have criticized these big language models because they say since they're trained on very, very large data sets, we can't really control what's going into these data sets and into these models. And in fact, these models regurgitate the biases which are out there. So by scraping data off the internet, we're learning these biases. And these models, we can generate language. They also can generate improper language, which they learn by reading this data. They also do this because actually they have very little understanding of what they're actually saying. And the two papers I'm referring to here, one is called Stochastic Parrots, and the other one presents what they call an octopus test, which is basically like a philosophical test similar to the Chinese room argument extended to large language models. So in a similar vein, here I want to discuss these issues for end-to-end response generation and dialogue systems. So the diagram you see here on my slide is the sort of standard architecture of dialogue systems. People are probably used to it. It consists of several different modules, all in a pipeline, including language understanding, dialogue management, language generation, and so on. So what happened in about 2015, now almost 6 years ago, is that people replaced this architecture with a neural encoder-decoder models. So it's basically a big black box where you've got an encoder mapping the input to a decoder. So it's similar to machine translation, where you try to translate whatever the user says into a system response. And nowadays, people probably not use LSTMs anymore, like on my picture, but now people moved on to transformers. But for clarity, I included LSTMs. They're just better to look at. So in general, all of these models are basically based on the idea that you've got this implicit input-output mapping with some hidden layers in between. So the really great and exciting thing about this is that there is no semantic annotation required. So suddenly we've got large data sets. So that's something which was unheard of. We were always stuck with these really small, painfully annotated data sets for building these systems. Now we've got big data sets like movie subtitles, or in fact, conversations scraped off the internet, for example, social media. So I will review these end-to-end models on two in 2 case studies. One case study is on task-based systems. So as you probably all know, these systems help the user to solve a task, such as booking a restaurant. And the other case study is on social or open domain systems. So these systems are supposed to be able to talk about anything. So first of all, for the task-based systems, we wanted to know how good are these end-to-end models really? And we organized a challenge in the area of data to text, which we called the end-to-end NLG challenge. So the task here was to map a data representation, in this case, like slot value pairs or predicate argument structures here in the first line of the table, to a well-formed utterance. And to get these well-formed utterances, we crowdsourced that and we released a large data set. We posed a shared task and we got lots of participants. And most of the participants submitted systems in this encoder-decoder based paradigm. So that's all the system encoded in red in this table. And what I want to point out here is what one of the main outcomes of this shared challenge was: the insight that these systems are not very good in being faithful to the input. Meaning we observed things like the system hallucinating things which weren't there. So here the system says, oh, this restaurant is in the low price range. However, the input doesn't say anything about price range. The second system talks about a pub, and in fact, it's a coffee shop. And the last system simply forgets to mention that it's a coffee shop. It's obviously not great if you've got systems talking to real people trying to solve real tasks. So the reason why this happens is what we call exposure bias in neural natural language generation. So in a nutshell, you train these systems using techniques such as maximum likely estimation or teacher forcing. And that's why they're favoring high frequency word sequences, and they're also penalizing length. So that's something to remember. I will come back to that fact. So the next thing we tried, we thought, okay, if they're not great for task-based system because they do all this hallucination, maybe they're better suited for social systems. Who cares about a little bit of hallucination in social systems? After all, they're more sort of chit-chat, entertaining, right? So here we entered the Amazon Alexa price challenge twice. And I believe you heard about the Amazon Alexa price challenge yesterday. So very briefly, it's a challenge where university teams are invited to build a social bot, which can talk about a whole range of topics and is as engaging as possible. And in return, the university teams actually get, or the bots they build get to talk to real customers, which is really pretty amazing for a university to get this type of data. So we built the system using state-of-the-art techniques, and we very early on found out that these end-to-end techniques for response generation weren't really suited for talking to real customers. So what our system did, it said things like, you will die, so short frequent utterance in the movies. At Christmas time, it told the children that Santa is dead. Sensitive situation weren't handled very well by our system, and it was also very ready to give financial advice. So this is a really interesting example because from a dialogue perspective, this is obviously a really good response, but Amazon wasn't happy at all and actually took our system offline until we were able to fix this. So we weren't the first ones experiencing this type of problem. In 2016, Microsoft released a bot called Tay on Twitter, and it was supposed to learn from live Twitter feeds. And it didn't take very long for Tay to become racist and sexist. And it also, in the end, told people why it behaved like that. So it's basically a classic rubbish in, rubbish out problem, similar to the stochastic parrot example I gave in the beginning. However, it's not only systems which misbehave, it's also customers which can misbehave. So that's also something we experienced, that we actually get quite a high volume of abuse or our bot got quite a high volume of abuse. So there are now two questions here. Well, the first question is, why do we care? So this is not a sentient being, right? So why does it matter if anyone abuses these type of systems? So the argument which the UNESCO brought forward in 2019 was that they are concerned that these systems are reinforcing gender stereotypes. So you probably all have noticed by now that most of these systems are anthropomorphized and also depicted as being female and very helpful. In particular, they give or gave not very good responses to when being abused. So the report, the UNESCO report, was entitled "I'd Blush If I Could," which was actually a response by one of the commercial systems to sexual harassment. So that's why we should be able to deal with abuse. However, detecting abuse is actually also quite tricky. First of all, we could obviously use things like keyword spotting, but the really difficult cases are probably not that straightforward. And that's work by my collaborator, Emily Dynan. She works at Facebook, and they build a model which they call Build It, Break It, Fix It, which basically iteratively trains on harder and harder examples by having a human in the loop, so a lot of humans, crowd workers in the loop, which produce adversarial data. So then, once we can recognize abuse, so this is by far a solved problem, but assuming we can, we need to be able to deal with it somehow, to mitigate it somehow. And here, me and my student Amanda started surveying existing systems, and we looked into data-driven systems, commercial systems, and then we also wanted to compare them against the baseline. And here we chose adult-only bots, so they were only available from certain websites. And the idea was that these type of systems would be actually a bit more positive towards that type of abuse we found in our data. So what we did, we took the abuse we got, or our bot got during the challenge, we paraphrased it because we were not allowed to release any of the data because of privacy issues. And we basically used it to insult a lot of bots, and we gathered the responses and analyzed and classified them. And we found that, as expected, adult-only bots are quite flirtatious, but they actually will also retaliate the insult, and they were the only ones chastising the user. Whereas data-driven systems, as expected, they talk a lot of nonsense. However, in the context of a conversation, their answers can be interpreted as quite flirtatious, and they're also ready to swear back. So if they see a swear word in the input, they're quite likely to also generate a swear word in the output. And commercial systems mostly avoid to answer. So the next question is then, what is a good mitigation strategy? And therefore we asked crowd workers to rate different mitigation strategies. And we found that there is no one size fits it all. So first of all, it depends on factors of the user, such as the age. Younger people really dislike avoidance strategies, for example, whereas older people really dislike jokes. And then it also depends on the type of preceding abuse. So for example, how severe that abuse was. Right, so this is a relatively new topic, and in order to investigate what people think this topic includes, we organized a workshop, myself and Emily Dynan, last October, which we called Safety for Conversational AI. And we discussed a whole bunch of things, including possible tests, benchmarks, data sets, and so on, but also we wanted to know what is safety. And one outcome of the workshop was that safety is very much relative to what individual people perceive, but also to different contexts. And there are lots of different contexts where this plays a role, for example, for offensive language detection, profanity, hate speech, pornographic or sexual content. Medical advice is another big problem here, including self-harm, substance abuse, and so on. So pretty much almost any application you can think of conversational agent could potentially have one of these safety issues. So finally, I want to point out how this is relevant to Alana AI. So Alana is based on the success we had at the Amazon Alexa Challenge, and we wanted to take the system we built and actually use it for a good cause. So our main mission is to use conversational AI to make a positive impact in society and use it to actually really help people. So therefore, we're using with a couple of big organizations, such as the Royal National Institute for Blind and Partially Sighted People, and also we're working with UNICEF. However, the drawback of, or the challenge of working in this area is obviously that we have to safeguard vulnerable people. And at the same time, we want to use state-of-the-art natural language processing methods. So here's the challenge. I'm aware I'm not giving you a lot of answers here on how to solve this challenge. As I mentioned, this is really very early work. It's really exciting to work in this area. Not much has been done. I'm happy to answer questions in the chat. There are a few research papers popping up here and there with initial ideas. But yeah, as I mentioned, it's a great area to be in. So finally, I have a couple of announcements to make in my last minutes of speaking. First of all, we're having a special session at SIGDIAL this year. Also, again, myself and Emily on safety for conversational AI. And we are also hiring, despite COVID and everything, we are hiring on several levels. Sorry, this is my alarm now. We are hiring research engineers at Alana AI. We are hiring at Harriet Watt. We are hiring faculty in machine learning for robotics. And we are offering several scholarships at the Edinburgh Centre of Robotics. So if you want to know more about any of these positions, please don't hesitate to get in touch with me. And I was going to play you a video of Alana in the finals of the Amazon Alexa Challenge. However, I don't have time for this now, so I will post a link into the chat on the conference website, and please feel free to watch it in your own time. So thank you so much. Please post any questions into the chat, and I will be happy to answer them. And also please feel free to reach out in other channels. It was a pleasure to be here and enjoy the rest of the conference. Thank you so much.